Okay, note that in this particular network, we have a little square that has 23 PCs in it. We're simulating 23 PCs because I don't want to drag out 23 additional devices and take up all of the workspace. So if we were to count all of the hosts on this particular network, we would count 23, right? Plus this one, it's 24, and each interface on the router gets an IP address. So it's 24, 25, 26, 27, right? All right, so within this square, we have how many devices? 23 plus this one is 24, 25, 26, 27. 27 hosts in this particular network. Okay. How many devices do we have in this particular network? 5. Okay. We have 6. Let's see, 1, 2, 3, 4, 5. Because we're not going to assign an IP address to the switch. We haven't done that so far. Okay. And then we have 2 more networks, and each of the other 2 networks has 2 hosts, right? Okay. This network has 2 hosts because there are 2 interfaces there, and this network has 2 hosts. Okay. Going back to the variable and subnet mask instructions, it says start with the network that has the most hosts, which will be this particular network. All right. Then it says determine the H or the least H value of the 2H-2 formula that provides enough host addresses for the above network. How many host bits do we need to leave or make available to create enough host addresses for this network? 2 to what power will give us at least 27? 2 to the 5th power? Okay, 2 to the 5th power. Okay, that sounds good. And the actual formula would be 2 to the 5th power minus 2 will give us 30. All right, so let's go to our chart, because we need to go ahead and calculate the subnet mask and then determine the network address. Okay, in this session, we're using 199.199.199.0/24 as the original range. Okay, we go to the chart. How many bits do we have to leave? How many host bits? 6. How many host bits? 2 to the 5th power. Okay, so we'll start from the host portion. We'll isolate 5 bits. Okay, so we know that these 5 bits are host bits, and the first 3 bits in the octet are network bits. Okay, so let's calculate the value. 199.199.199. We know the first 3 octets will be 199 because we're not manipulating anything in those octets. Now, what's the value of the last octet? If we were to assume that all of the host bits are zeroed out and then the network bits are zeroed out, then we're going to come up with the value of 0, right? Okay. And what's the subnet mask? It's going to be a slash what? Slash 20, slash 27. How do we get slash 27? Yep. Okay. All right. What will be the broadcast address? 199.199.199. Well, to calculate the broadcast, we need to turn on all of the host bits. Add the host bits to the network bits, and we should get 31. Okay. All right. So we've looks like we've pretty much calculated the first subnet. Okay. According to the instructions, it says this will be subnet 0 or network 0. Yes, it is network 0. And then we need to assign the addresses to the devices. Okay. Let's start with router 2, and we're going to configure F0/0. Okay, what's a good IP address? 1. Okay, what about a subnet mask? Can't stay as it is, because as it is a 24. And if we were to go back to our chart, we see that this is that first network is a /27. So what's the dotted decimal? 224. And we'll go ahead and turn on the interface. Okay. All right. What about this router? We're going to configure F0/0. Okay. What's a good IP address? 0.2. Okay. What about a subnet mask? Same as before, because we're dealing with the same row on the subnet chart. Okay. All right. And we need to configure what looks to be F0/0. I had to move the route around to see the interface label. Okay. .3, and subnet mask is 224. Turn on the interface. All right, let's go ahead and start configuring one of these 24 devices down here. Okay. What's a good IP address? Can I use .30? Can I use .30?
No.
Sure, because it's between 0 and 31. Okay. I can use .30. And okay, and is the subnet mask correct? It's got to be consistent for the network. Okay, and what about the default gateway? What's the default gateway address? What's the default gateway address? It's a little tricky, isn't it? We assign .1 to this router, .2, and .3 here. Okay. Now, for the sake of this session, we could assume that each of those routers lead to the internet. So we have an option. We have the options, right? Okay.
If it was like a real setup, could you use one for all?
Okay.
Is that realistic?
Realistically, in the real world, you could distribute this task. For example, you may want to assign 10 PCs to one particular router, and another 10 to another, and maybe the last 4 to the third router, okay, in terms of default gateway. Okay. So we'll select one of the routers. I'm going to select .2.
You just make the workload easier on the rest of it.
Yeah. Okay. All right. So we completed one network. All right. Okay, now let's go back to our variable length subnet mask steps. Okay, we're going to section 2. It says determine the next network that has the most hosts. Which is the next network with the most hosts?
Bottom corner of this.
Okay, and this has how many hosts?
No.
5 hosts?
Yeah.
5 hosts, okay. All right, and okay, we'll go to the next step, which says determine the least H value of the 2H minus 2 formula that provides enough host addresses. So what must H be to provide at least 5 host addresses?
H is 3.
H must be 3. So 2 to the 3rd power minus 2 will give us 6. That will work. So we'll go back to the subnet chart, and we're going to go ahead and demark those 3 host bits.
Okay. It's making better sense now.
All right. So we need to go ahead and determine the network address. Let's look at the instructions. Okay, it says use the network bits to calculate the subnet mask for this network. And then it says this will be the next available network without conflicting with the range of the preceding network. Okay? So we need to calculate the subnet mask, and it's going to be /29. Okay, /29. Okay. Now let's determine the network address. 199.199.199. What's the next available bit combination we can use without conflicting with the preceding range? Can we use the 16-bit only? Mm-hmm. Excuse me? The 28 bits? We can't use the 16 and the 3 host bits, right? Because that'll cause a conflict with the preceding range, right? Can we use the 16 and the 32? Yeah, because that'll create the 48 network, right? But then we'll skip the 32. Can we just use the 32 by itself? That would be more practical because we don't want to skip any. And if we go back to the instructions that says the next available, so we don't want to skip any. Because if we skip, then we're going to be wasting IP addresses. Okay.
See, I was thinking 32 is the broadcast. I forgot that caller is the broadcast.
Okay, so this will be .32, and we need to determine the broadcast address. To do so, we'll have to turn on all of the host bits. Add the host bits to the network bit, and we get, so we're adding 7 to 32, 39, okay. All right, now we need to go ahead and assign addresses to the devices. We'll start with this router, and this looks like F01.
Is that really 2 different routers?